Have the recording start. Let me just share my screen. And what I wanted to show you is a bit of the Edge workflow so I can mention with you what we have done. And in this moment right here, I want you to take a look on the things that I am saying, that we are talking about, because if you have any doubts on this more fundamental part, or if you have any doubts about something on the workflow right here, just tell me and we are going to go for the project and take a look where we can find it. So we have started in our project, seeing on the first day, second day, and yesterday, the histograms, scatter plots, QQ plots, box plots, and the compositing. We have checked yesterday some of the options that we are going to have for the compositing. What we also have done during this modulation, we had separated our domains. So we know that we have our gold domained in the vein and domained on the QPZ. So if we wanted to carry on in our if we want to carry on in our project right now just doing these statistics, we could because we already have this project for it. So we have our domains already classified by the geological model, and we can input some variograms and estimations if we want. And of course, we have already used some of these standard estimations yesterday and generated our block model. So as I have already commented yesterday, we have here the trigger block model. So when we have the block models, the one that is part of the edge extension is going to be the subblocking. So when we are talking about the regular block model, we will have this option available, but we cannot do any kind of evaluations, reporting, or triggering. So what that means that the edge extension is the one giving you all of those options and also the options of doing the kriging on it and also the calculations. And the reporting, we have seen yesterday that we can do the great tonnage reporting and also some validation plots. What are the validation plots? The sweat plot, the parameter report, and the interrogator estimator. What that means? That means that if you want to see, to check statistically if your data is behaving well, it's not under or overestimated, we can do that by those little validations right here. So I am going to open now the project so we can take a look on it. So we have seen the block model yesterday. We have this right here, our block model constrained to our QPZ right here. And what do we have here? We have triggers, we have evaluations, and we have graphs and tables. So all of those options right here from evaluations to the bottom of them, they are from Edge. Also, other parts that are from Edge too that I have already commented that are here on this little workflow that we can download it on the sequence learning. This is a part that I'm going to enter with you by the end of the course, where you can find all these informations that I am saying, that I'm telling to you. We have this step by step online. So you can have access now to a bunch of new material and the next one that I'm going to provide to you so you can be able to carry on upgrading your skills is going to be the one of Edge. So it's one project, and I'm going to pass to you as a homework if you want, because this is the way of consolidating everything that we have learned. So this little course right here, you are going to take a top 10 hours to do that, to finish that. And you have those little visual resources for you to, if you have any doubt. Also, you have the support. And what I wanted to tell right now about our little workflow that we were seeing right here is that we have the estimation of the domains. And on these estimations of the domains is where we are going to do our variograms. So coming back right here to our project on Leapfrog, we have right here the estimation file. So right here on your project tree, you have your estimation file, and you can right click on it and select a new domain estimation. So we can do a single domain estimation or a bulk of them. In this case, we are just going to do a single domain estimation, and we have this window open right here. So why we are doing that? This is the place where you have to do your domain estimation so you can be able to apply your variogram or your ordinary kriging or whatever the statistical analysis that you want to apply here. So what we are going to do, we are going to select a domain, and this domain will be selected by our geology because we know that our domain will be our vein in this case. I don't want to do a multi-domained one. I just want to do one domain. So doing the domain right here and separating already the volume that I wanted to it, inputting the boundary, I will already have my graph from the boundary. So right here, we could understand in the hard boundary the domain that we have. So from here to here, we have way more data than here. So we can see the samples count and the mean value right here. So the mean value is way higher inside than outside, although we can see that we have more data outside. So we can already take some ideas from it. If we were planning, for instance, a new campaign, we would know that in this new drilling campaign, we will have to get more information from inside our domain. So this is an easy way for us to already do really harsh analysis, so analysis that are a little bit longer. And as you could see, once I have clicked on the estimation, we have seen here the processing. So exactly what Arushi was asking, we have here the test completed, and it was pretty fast, so it didn't take any time. It was not even a second, but we are going to have this right here appearing the amount of time that it's taking. So now that we are seeing right here the estimation, we can just check how this is behaving, and we can see how the estimation is working and the gold values that we have. So the gold values, they are here, and we can see the domain with a little bit of transparency, and here the gold, the values of the essay that we had. And by this, we can start to do our spatial models, variable orientation, sample geometry, and estimators. In our estimators, if you right-click on it, you will see that it's right here where you're going to do inverse distance estimator, nearest neighbor estimator, new kriging estimator, or a new RBF estimator. So which is this part right here on the workflow? On the workflow that I was saying, this is exactly the part that I'm talking about. So the variography and estimation of the domaining. So we have already covered this part right here, talking about the basic statistics and everything that we can get from our interval selection until we get our statisticals about exactly what we are searching for in our project. And now we have how to do the variograph and estimation on the domains. So we have already checked the block models and also the graphs and reporting. So now that we have already done this little part right here, we can come back to our project. And on this project right now, we are going to take out everything. We are going to come here and collapse the tree by right-clicking and collapsing all the rows. And now we are going to bring in right here our geological model. This geological model that we are bringing here can be the statical one or can be the new one that has all the data. It will not make difference, but we are going to use our GM geology, which is the one that it's more complete. So you just need to drag and drop to your scene view, and you will have this right here. So we have our model right here and intending that we need now to show this information to our investors, to other people from our team, or maybe to some people that are not users from Leapfrog. What we are going to do, we are going to use those two sections right here, the saved scenes and markers and the sections, plans, and contours. So we are going to start by the save scenes, movies, and markers. This one is pretty nice if you need to show this data to somebody that doesn't have this much um, of timing with 3D features. So if you are talking to somebody that is not very aware of 3D features, if it has some kind of difficulty with it, the best way for us to show it, it would be if it was turning around a little bit. So this way the person can see all the axes. So tell me, Anushi.
Julia, there is some issue with your voice. Like it's breaking after some time. 3 times it is like breaking.
Um, Sorry, what it is? You were able to open the project, right?
Yes, yes. I was saying there is some issue with your voice mic.
Oh, got it. You are not hearing?
It is fixed now, but sometimes it is like alien like voice.
Oh, oh, got it. Well, I hope that this doesn't make any trouble for understanding. If you just
It's
pause
better
me
now.
if is needed and I can repeat it again, the parts that it was not able to understand. So I guess that by tomorrow I will have this sorted out, but hardware problems are always this headache.
It's okay.
Well,
It is fine now. It's fine now.
so just let me remember a little bit. We were talking about the saved scenes to do a little movie. So what we are going to use the saved scenes, movies, and markers. If we right click on it, we can already do a new current scene. So we are just going to do a tryout here. I want you to import the topography for the visualization. So we can input right here our topography. If we want just to insert right here the flat column, if you prefer that, there is no problem. And we could take save it scene. So you can right click on it. We can import do a save current scene. And when we do that, when we click on Save Currency, we will be able to do a description and to put a name on it. I will say to you to already insert here numbers. Why? Because with your scenes, you will be able to construct your movies. And your movies, you will be able also to export it on a .movie kind of archive file, and this is going to be very awesome for you if you have any kind of presentation for investors or for your bosses. If you need to explain where the resource is coming from or where the calculation is coming from, you can do this tiny movie right here. So by selecting the scenes first, so we are selecting the scene with the topography, and we could input a description right here. We could input topography if we want to and just click on the OK. And then we can take out the topography and do another scene with our geological model. So this is going to be the second scene. we can input as GM because we are seeing right here the geological model. So we just need to click on the OK and we will have two. And now just the last one for us to check out, we can change the angle if we want right here because this will be shown on the movie. So the rotation to it will be shown on the movie too. So if you want to do that, just to change a little bit the orientation here, it will work. So now we just need to take the other screenshot if we want to, and we can also edit the colors. In this case, we wanted just to have the vein and with the maximum. And on the easting. So, oh, sorry, I forgot to press save. Why, when we do that and we take out the colors, we need just to press on the vein and then press OK to get it. And remember, if you input your geological model again on the scene view, what is going to happen? You will only see the vein because you have untickled the rest of it. You just need to come here on the editing colors and put the visualization for everything. So right here, we are just going to save our last scene, and it's going to be our third scene. And this one is just our vein. So I'm just going to explain here vein and click on the OK. And now we can do a little movie. So right clicking right here on the saved scenes, movies and markers, we can do a new movie. So when we are right here, when we right click on new movie, we will have this new tab open. So with this new tab right here, we will be able to select our scenes. So if we press the blue one, Control, we can take our scenes to our storyboard. And what that means, we can see right here when we are adding our scenes to our storyboard that we also have a transition time. So this transition time is always set at 10 seconds and changing to the smallest angle. So in our case right here, we are going to decrease that for 3 seconds. And on the other one, we are going to decrease that for 3 seconds too. On the properties that we can see, and then we can select them all. And by selecting them all, we can render our movie. So if you check out right now, we are seeing the little movie that we have done. It's a bit stuck right here in my computer because I also have Teams open. So it had just rendered it. And we could see how it works, our little movie. And to save it, we just need to press it save right here. So if we save it, I just had did it. So if you click right here, it's going to appear right on your project tree. So if you check below your saved scenes, movies, and markers, now you have the movie. And if you want to rename it, you just want to right click on it and rename it. If you want to export it, just click on the export and you will see that we can do the movie size, the frames per second. So if you find that this is too stuck, you can make the frame per second higher and you can make the quality high too. Here we have the total duration and you can export the frame images too. So once you do that and you want to export it, it will be exported to the file that you are choosing. And right here, we can see that the format for it would be WMV. And I'm not going to save it right now. If you want to, you can do it. And now that we have checked how to do the movie and how to save our scenes, I'm just going to close this tab and we are going to come back to our geological model. And on this way right here, I'm going to edit the colors so we can visualize everything again. So now that we are visualizing everything again, what we can do, we can now do the sections, plans, and contours. So right here, when we have our sections, plans, and contours, what are our options? We have our new cross-section, a new long cross-section, a new serial cross-section, and a new plan view. So now let's just take a look on a new cross-section. So when we input a new cross-section, we can see that we have some options right here. If you want to make it a little bit more transparent, you will see that we have right here, I'm going to take out the visualization. You have here on F, the front. So what is the front? The front is the front of your cross-section. And the backing will be B. So pretty intuitive. And right here, what you can do, you can swap it. So if you want this to be turned around, you just need to swap it. If you want to make it bigger, you can make it bigger too. And if you want to make this align it to a section north-south or align it to a section east-west, we can just click right here. If we want a different dip, a different azimuth that we have the number, we can input also right here. And the naming, we can change the naming, but by default is going to be the naming of the north or the easting if it was in the other direction. So right here is going to be the basic part of our new cross section, and this one is going to be the one that it's the one that we are more used to. That is the one that is just normally cutting our geological model. So we can see right here that this is cutting our geological model. And what we would need to do now to have this cross-section showing us what we wanted to see, our model, we will need to do a template for it. So if you come right here, you can choose a new layout template. So when you do a new layout template, you can decide also the location and just do the next. So you will have right here your layout template. And on this layout template, we can choose right here to add the models and add everything that we want. First of all, I just want to, before we start to input anything on our cross-section, I just want to mention the parts of it that we can change in our vectorial. So if we double click on the location, we will have right here open. We don't need to click on the location. We can click right here on our page, what's being shown. We can input text boxes. We can input also images. So for instance, if you want to input right here a little location image, you could put insert. If you want to change those places right here, if you want to change the scale, the bar style, the length of it, the line wild, you can do too. And also the legend that is going to be attached to the file that we are choosing to input to see here. And right here, we also can change our layout template section. So what this means right here, that we can feed that to page, we can change the X and the Y extenders, and also we can do some evaluations on the extenders. We can input the project units right here if you don't want them to be the same of your project. So for instance, if you want right here to be shown in kilometers, you could, you just click right here, just try to be consistent because the program is not able to do any conversion. So if you are using meters and input inches right here, you can have a problem. So I am talking here about changing meters to kilometers. This is different from changing meters from inches. So just to mention that part, and the location that you will also have here. You can input a title on it, you can change the heading, you can show the Z coordinates, and this is the mainly of our cross section and how we are going to do that. I'm just going to import a model right here so we can check out how this is behaving. So I'm going to import the geology right here. And you could see my processing done right here. So right now I had to process 14 files to see this right here. And it took 2 milliseconds to do that. So the processment will be always showing right here. So this is also the place that I have told you to check a little bit if you are having troubles on the processment. So if it's taking too long for you to open something or to visualize something, you just check right here on top if it's paused. And if it's paused, you just need to run all. So now that we have checked right here our layout templates, we could see that by selecting the geological model right here, I have this already displayed. So here is my legend too. Here is my location. And here is my scale bar. Of course, I could also input the text boxes and the images. Now, let's just take a look if I'm going to save it. And now let's just take a look how we were going to do that if we were trying also to do a new cross-section that is deviated. What that means? That means that we can do a cross-section that it's not actually straight, that has this deviation in any points. And how we could do that? We can do that by doing the looking down and constructing a polyline right here if we want to. So right here on the polyline, we can build a new polyline and use it to do our new long section, or we can just do this directly right here. So if we input right here the new long section, in sections and plans and contours, we just need to right click, new long section, and we can do that by a new polyline too. So I was saying that we could done from a polyline that was already existing, or we can do a new polyline to do that. So we can also choose if we want this to be an entire one or multiple sections. And of course, the name of it. And I'm going just to do a new polyline and click on the OK. So when we do that, we are going to have the drowning options right here. So talking again about our drowning options that are appearing right here, which one we should choose? We are trying here to construct a polyline and exactly on the place that we want to see. So what we are going to do, we are going to draw a line. To do that, you can choose the place that it's more comfortable for you to take a look. I was telling before, the down vision is generally the best for it. So I am just going to construct a polyline here that is going to be here and here. You can do uh, the tryout that you want to do, because this here, we are just going to try out how this happened, and we are just clicking on the OK. So now we are saving it. We are on the process of saving. And once it's done and it's already saved, we can take a look on it of how this is happening. So we can just go to the long session now and take a look how it is. So this is our long section. What we are going to do for the long section, if we want to now visualize things on it, the same thing. So right here on the long section, we are just going to call for an evaluation if you want. And in this way, we are already having everything that we want on it. So for instance, if I want to have my numerical models, I would just need to input right here and just click on the OK. So we could see that we have now the evaluations of the surfaces also in our section. So what is pretty nice right here that we are having, we can do the deviation. We can also do curved ones. So if you want to do a curve or something that is spherical, we also can right here. So right here, we have already checked how we are going to do the templates, how we are going to do a section that has a deviation, and how we are going to do a new cross section and the layout for everything. So now we just need to check the last one, that it's going to be our new plan view. So what is going to be the plan view? Let me just take out our long section right here and take out our section and take a look on our geological model. We can see that the plan view is going to be the one that is horizontal. So in the exactly same way that we had the other ones, we will have this one that is horizontal. And by choosing right here, we can name it plan view and just do the OK for it. And we will have the plan view right here. So this is going to be the surface of our cross section. And now, just speaking a little bit about our templates, if we want now just to save it or to export it, how we would do, we could copy this layout template too, which means that we can, oh, sorry, if I close here, it has to be closed. You can copy layout too, and you can already use the same layout for your long section, for instance. And this one here, this step right here that I'm showing, this is very important if you are doing a new series. So what is going to be a new series? Is going to be this option right here, the third one, a new serial section. So what is going to be that? It's going to be a bunch of sections that you need to do along your project. So let's do just an example of the new serial cross section so we can be able to put the layout in everything at once. So closing right here, taking out our plan view. Now we are just going the new serial section. So when we open the new serial section right here, we will have the options of spacing it. I'm going to change the spacing for 100. And we can see the change. We can also see the front and the back written right here. We can determine the dip, we can determine the location, we can swap the fronts, and we can enclose to a different object. So let's just take a look. If we want to enclose this to another model or for the block model, we could. If we want to enclose this just for our drill holes, we also could. So for instance, if we want just to take a look on our essays, we could just enclose this in our essays. As our geological model was done based in our essays, this is going to be the same boundary, but this could be a change if you were using an essay and a different boundary for your geological model. And then you can just click on the OK, and you will have all these sections right here. And what we could do, we can open and copy the layout template to those sections. So we could choose now the sections and plans, this series that we have done, and just click on the OK. So now that we have clicked on the OK, we can expand it and see that we have a layout for it. If we want, we can input in our scene view right here to check if this is making sense or not. And right here, if we double click on the layout, if we right click on the layout and open it, it will tell you if this is the original layout template or if you need to see the original template. So this one right here is telling me that this is a child of the template. So this means that I have to go to the original template to open it, and this way we can change anything that we wanted that is based on the editions. So those parts right here, they are the editions. So now that we have already talked a little bit about our plan view, our cross sections, you could see that we can also create a new series of slices right here. So if we want the slices to be a series, we can just come right here, do the slice, and do the create set. And we can create a set. And when we create this set, we can name it and click on the OK. And we will always have this set right here to see and check if you want. And just clicking on it, you will be able to see your set again. So these are going to be the mainly ways for us to export our project in a 2D view, so the cross sections and everything. And now we just need to check out right here in our little data course what we have for our section from the weathering. So we have right here our section from the weathering too. This was exported from the original project too. And we can see that this is a normal PDF or a TIFF file if you want. But in general, we are always exporting in a PDF. You can choose because right here, we can right click on it. Oh, sorry. We can right click on it and take a look and save it. And if we save it, it's going to be all saved here. So right now, do we have any doubts on the visualizations, on the 2D exportings? Something for us? I have already commented on the notes too, on the coloring, that we can catch the coloring, the color gradients from our determined color on the raw data. We have talked a little bit about changing the categorical data, the numerical data to categorical. We also have worked with some of the estimations right here and check out that we could use right here the new inverse distance estimator, nearest neighbor estimator, kriging, and RBF estimators in our domains right here in our file estimation. We can also sample the geometry by declustering the object. And what means declustering? Separating the data. So if you have a lot of the data in one place, you will need to decluster this a little bit so you'll be able to understand the geometry of what you're seeing. And this one right here, it's pretty common one of when we are dealing with structural data. So the variable orientation, and the space models that we can do a new variogram directly. So if we check the variogram right here, we will have all the variograms options. So the seal, the normal seal, the type that you want to. So the type can be the linear, spherical, spheroidal, Gaussian, exponential, cubic, and generalized Cauchy. This is going to depend on the statistical method that you are using. Here you can input more than one structure, of course. We are just inputting one. And here are a little bit of the variogram for the golden values right here. So this is the major, the semi-major, and the minor line. So if we want just to take a look on the minor, if you want just to take a look in the same major, if you want just to take a look in the major, we can do that separately too. And we can set from a plane and view our ellipsoid too. So this is a little bit more advanced of the edge, and it's going to make part of your homework because this is the part that we have also step by step on that little course that I have talked a little bit about in the beginning of the section today. So now let's just closing this a little bit. I just want to check with you if there's something else that you want to see on this project. So after the interval, we can start our historical data project. So please just tell me if you have any problem into this moment. And if you can get the presentations, yes, I'm going to make it available for you too. But all of this data, you can find it for free too on the internet. If you just, I will share with you anyways. And now one thing that I wanted to be aware, you have licenses and you have licenses for, I think that it's going to be, if you check out the expiration for me, I think it's going to be, you can check the expiration if you manage your permissions is going to appear right here. As you can see, I am not on the group of ERH anymore. So if you check out right here, you will see how much time do you have for your license. Generally, it's 2 weeks and your license had started on the day 4. So I would believe that until the 15th, you may have the license. And on this meanwhile, you'll have a lot of time to check right here. If you go to the Sequent Learning Center, we can just see it right here, the catalog. And on the catalog, what I wanted for you is for you to take a look on the things that you have here. And you could see that you have the Leapfrog Edge fundamentals, that it's a little bit more intermediate. So if you are able to accomplish everything on this 16 hours that we have, talk a little bit, you will be easily um, you will be able to do easily this course of Edge Fundamentals. And of course, you'll have everything guided here and also the workflow for it. So each step, each module is explained very, um, very deepening. So if you just press the resume, I just want to show you how this works. So everything that we were talking about the variogram here will be more explained to you, and you will just need to follow the errors. So you can create your initial variogram. You can understand here a little bit better with images how this is working or if it's not working. And in this case right here, you are going to work it with a project called LEDA project, where you have to do 2 domains. So it's a practice really interesting for you before you starting using on your data. So just showing a little bit more, it's pretty easy for you to understand how to do the course right here. and you can have those tasks. You can come right here for the task, and on the task, creating a new variable model, for instance, you will be able right here to check how this is going to be done. So you can click right here, and click right here to get the informations. And of course, you will have in some tasks of it a little video showing how to do this special test. Right here, the step-by-step of this introduction course to the Edge is very easy. So we don't have a lot of videos on it because just with the step-by-step, you will be able to follow everything through. So for this little course that we are giving, we also have this step-by-step, and you can access in the same platform the sequent learning. So now coming back here to our project, if we don't have any doubts now, I would just call for our little break, and afterwards we can start our new model. So this other project is called Sigan Valley and is totally based on the geological mapping. So we'll be back in 10 minutes. Please tell me if you need more time. I am writing on the chat right here. And in 10 minutes, we are back. Hello, hello everyone. So we are back from the break. I hope that you were able to fresh up a little bit. So please tell me, do you have any more questions for the last project? I'm just going to do a short review again, just to be sure that we had everything covered. So if you have any doubts or in any of those items that I'm going to speak about now, just stop me and I can explain it again. So let's get over again our project that we have spent those last 3 days on it. First of all, the topography. When we have a topography, we can input right here new high data that is coming from other sources. So if we already have a mesh right here, we can add this high data. And what we can do if we have two meshes and we need to insert it as topography. We are going to import these meshes from our computer, and then we are going to do a mesh operation where we are going to merge those two meshes. After we merge those two meshes, we can just import it to the topography. So I'm just saying here some cases for us that we will find in our daily basis of modeling. So if you find that any of those cases may fit for your case, it's good for us to already have this um, clear. So right here we can check that our topography was done by our Oliver topo points. And if you don't remember where your Oliver topo points are, you just need to click on it because every time that we have something linked here, when we click it, it will open on your project tree where this file right here is. So for instance, if we go right here in our meshes and we click on this simple pit surface, we know that this was bring it on right here by this. So it doesn't have any kind of link to it. When we are going to have a link to it, when we are bringing the information from our project, that means that the analysis was done entirely on Leapfrog. So the GIS objects, if you right click on it, we can see if we just expand it, we can see all the draped GIS objects. What is the draped GIS object? Is everything that you have on a 2D surface that you want to see on your topography. Drop it. And how we are going to drop things. We are going to right click on it and on topography, and we will be able to drop it on the topography this way right here. So when you are trying to drop an object, remember, right click on it, drop it on topography. And another thing that it's very important for us to be aware, when we are talking about points and lines, they also need to be dropped on the surface if you want to see this on the topography. So the drill hole data, we have inserted our drill hole data, our all data, and our phase one data. So right here, we have the planned drill holes and the drill hole correlation. We have checked yesterday a little bit of the drill hole correlation, and we can see today a little bit about the planned drill holes. So as I had already spoken, we can, with the numerical models right here that we have in our project tree, do a distance function. And this distance function is going to work as a buffer. And if we want to have this distance to traces as something to analyze for our next planning, we can do that. So we would need just to open it and to check the buffers if they are making sense, and this is the distance that you want to check on your surface. So after doing that, we can just come right here and take a look on the output volumes, and just separate those volumes that we want just by the 25 or the 50 or any kind of number that you have decided that is the distance that you want. And you can use this to start planning your drill holes. And how you're going to plan your drill holes? You are going to do that by the new drill hole group. And how you are going to plan a drill hole that has a deviation on the survey? We are going to do that by a new multiple deviation hole. So I'm going to click on the new drill hole group and input our topography right here. And we can check that. We can input the prefix right here. And for us will be our phase 3. And we can input right here the name of our project right here, this new phase 3, for instance. And we can input the name right here and just a symbol right here. So if we want, we can just input like phase 3, and this is going to be a prefix to all of our drill holes that I will generate. So for instance, I'm just going to click on it, and you can see that we already have right here our drill hole 1 from the phase 3. So we can specify the color by doing the location right here, or we can specify the targets by inputting that with our mouse. So now that we have checked how we are going to create our new drill holes, we can check how we could lift it, how we can drift it, and also the dipping direction that we want. So the name is going to always follow the rule that we had settled. So this was the phase 3001. If I create a new hole, the phase 3002 is already appearing. So this right here is an awesome way for us to be able to plan our targeting and how we can afterwards evaluate that to check if this is fitting, and we can see if this is matching to our geology, if this is actually achieving something in our geology. We can just open it and do the editing if it's not getting to the place that we want. So we can input right here the amount of distance that we want this to come up, and then input our vein. And this way, our vein. And this way, understand that if our drill hole is going to intersect our already modeled vein. So this is a way that you can use to plan your drill holes and expend way lost energy on it, because you can already predict the place that you are that you are going to find the lithology that is on your interest. So after we checked a little bit of the drill hole data planning, we have already seen the drill hole correlation too. And now we can check the designs. We didn't have imported any design, but this is going to be the mainly way that you are going to import anything that you have built that is a 3D surface, not a block model, a 3D surface that it was built on Datamine, Serpec, Vulkan, or any other kind of 3D modeler. AutoCAD the same. So carry on here through our project tree. Now let's just talk about the points that we can import the points, do new points based on our contacts, guide points, intrusion veins, midpoints, and a new grid of points if it's necessary. So for instance, if you are trying to do a new campaign, a new sampling campaign can be just a soil campaign. You can do that by the new grid of points. So you can plan your whole campaign by the new grid of points. The polylines are going to be very look alike what we have already spoken into this moment. We can import something that is shape. We can import something that is CSV. We can import the Leapfrog model for it, that is the LFPL, ask, DXF, text, and any kind of general polylines that we can construct on GIS and on 3D softwares. So the geophysical data, if you right click on it, we can also check how we can import the 2D grids by local, how we can import the 3D grids by local too, and how we can import some of our DFN files. So carry on a little bit in our structural modeling. We are going to talk about this a little bit now on the historical data, so I will not cover this again. It's just the meshes that we had already spoken, and we can take a look here on the options that we have. Why? Let's just pretend that you want to do a new interpolant mesh that is based on the first mesh that you have. We can do that. We can do a new extruded mesh. So if, for instance, you want a boundary, and you want a boundary that it doesn't have this the boundary format that is a square, you can do a new extruded mesh that is going to be a mesh that is entirely 90 degrees if you want. So if I click right here, we can take this mesh based on a polyline that is existing or a new one that you're going to build. You can set the elevation to be extruded, or you can set the distance to be extruded. So what that means? That means that the extrusion is going to be down in this. And this right here, the extrusion is going to be horizontal. So this is a way for us to do new boundaries based in our limits too. And now I'm just closing here. Sorry? Sorry, I thought that I heard something from the audience. So now the meshes right here that we have already did the extruded one, the geological models that I have already mentioned that we can do a refined model too in advanced settings. Right here, the estimation. This is the file that only exists on Edge. So there is a bunch of little edges addictions right here through the project, but this is mainly the file that you cannot access without Edge. Also, on the numerical models, the distance to traces we will not be able to do without the edge extension. And carrying on the combined models, we can, and the block models. The block models, we cannot do this subdivision without the edge extension, not even the triggers or evaluations and reports. The saved scenes and the sections right here. So mainly, this is just a final overview of our project. So if you had any doubts right here, this is the moment. If not, I am closing right now for us to open our new project. So if you go here to the tab projects, you can see that we can create a new one. We can create a new project. So first of it, let's just check on this last project how you are going to save it. So let's just come right here on the settings and see our options. We have the option save a copy, save a zipped copy, or compact this project. What I would recommend you is always to do save a zipped copy, process it. So in our case right here, I'm just going to input the name of it, and it's going to be our final Oliver day. And we can save it. So you can see the saving copy of a project right here, and it's done. Well, Now we already had saved our project. We can close the program. What you are going to do if you release your seat, you are going to have to sing in again on Leapfrog. What is going to happen if you just quit? After when you open Leapfrog again, you will be able just to open without having to sing in again. So I am just going to click on quit and the program will be closed. So, do we have any doubts around here? Because now we are coming back to our little gel found file because we have there our zipped copy building a model from a map that we are going to use right now. So, when we unzip that file, first of all, unzip that file. It's very important that you do that. And we have here the topography. We have here the Sigan Valley map. And we have here some structural and GIS data. So what we are going to do first, we are going just to take a look on the Sigan Valley. And this is the map.
Julia, I have a question.
Tell me.
Now we are going to do creating a model with using the maps. So in the same way, can we use the geophysics data to create a model?
Yes.
Okay, thank you.
Exactly. You can. This is going to depend on what you want to do with this data. So if you want to become this a topography or if you want just to be a mesh that you are going to use along your project too. So there are two options for you. And in this option right here, we are going to do from the stretch because what happens? We need to georeferentiate this image right here. So we have all the informations on the image, but this is just an image. It doesn't have the georeference. So we will need to do that on Leapfrog. And this is the part that I wanted to show you, which make Leapfrog pretty easy to use generally. So let's open Leapfrog again. Now, what we are going to do, we are going to create a new project. So we just need to come right here, a new project. And in this case right here, I'm going to input the same method that I'm already using in general, that it's inputting first your date and then the name of your project. So this right here is the Sigan Valley project. I have inserted the day of today. And now we just need to click on the OK to open this. Oh, I am just 1 second. I think that I have my C disk full. Just one moment. Oh no, I don't. Just my computer was just complaining a little bit, but I am just going to start over again the Leapfrog. So one thing that I wanted to mention to you is this right here. So this is something that doesn't have much to do with the software, but it's also very important for us. You can see right here, this is my C disk. You can see that on my computer right here, I have a bunch of data, and this can become a critical stage. If you are in a critical stage in your C disk from your hardware, you will have problems on your graphic cards. And Leapfrog basically is going to use your graphic cards. So be aware that you are not having a full computer, because if you have a memory that is too full, you may have trouble with the software, and not just Leapfrog. In all the softwares, you can have kind of troubles with that. So now that I have made my C disk a little bit less heavy, we can carry on with our project. So we have again our Leapfrog right here. And before we start this new mission right here, I just want to show you how you can test your graphic card to check if it's going right with the project. So with the software. We have right here on top Leapfrog Gel. If we click in this corner, in this left corner, we can go to diagnostics. And on the diagnostics, we can test the graphics. So if you click test the graphics, this is going to appear to you, and you need to check if the images are matching. So for me, those images are matching, are matching, are matching, matching. They are totally matching, and you have to pay attention if they are really matching. The same thing right here, if the colors are the same. Right here, if the transparency is working fine. And here we can see that all the test matches, so I can save the report if I want or not. And here is telling me in which stage I am, if it's a full acceleration, partial acceleration, or software rendering. If you have in full acceleration, you are using the program features with my, in this case, video card, and this is going to be faster. Right here on the partial acceleration, we are going to use a fixed old pipeline, and this work with lower features on the software. This is going to be basically if you are having a pretty bad connection. And right here, the software rendering also. You would use pure software to render the 3D scenes, rather than the video card from my computer, from the computer that you are using. But we will work, besides it works in any hardware, it's going to make you see less features and less resolution. So maybe a bit not too well rendered image, a bit of edges and things like that. So just considering this, we can now start a little bit our project. So we are just going to start right here by importing the map and creating the topography. So we are going to first go for our GIS data, maps, and photos, because we are starting by importing our map. So we are going to right click on it, and we are going to click import map. So right here, we need to come back to our file that is going to be building a model from a map, and we are going to get the Sigan Valley map and just open it. Everyone was able to open the Sigan Valley and is able to see exactly the same window that I'm seeing here. I hope
Yes,
so.
Julia, yes, yes.
So just for you to be aware here, to see better, we can scroll in for the zoom, and we can right click on it and try to change if this was a bigger, if we go to the zooming, then we can do that. But this is important. Why? Because now we are going to follow exactly those patterns. So you can see right here that we have a square that is yellow. So we have a square that is yellow. What we are going to do, we are going to bring it on the intersection of some place that we know the coordinates. So right here, we have it right on the cross. And to do the cross pretty right, just give a zoom in and a zoom out. And be aware that you will have to fulfill now is this part right here. So, talking about the x, if we are talking about the x, this is going to be the number 750. If we are talking about the y, the north, it's going to be 3,000. So now going for our little blue one. I am just going to come closer here to do the same thing. And we can go up again and then check the blue one right here, which is the x is the same. So 750. And which one is going to be the y? It's going to be the 1,500. And now, by last but not the least, here we have the green circle. If we come really close here, we can just insert this on the intersection. And by pushing out, we are going to do exactly the same again. So on the X, we are going to input 2250. And on the Y, we are going to input 3,000. So after we done that, one thing that I wanted to mention pretty clear here, when we want now to save it, how we are going to do? We are going to import. Why? Because we were trying to import this image and then the software is telling us this image cannot be imported because it doesn't have coordinates attached to it. And then we are inputting the coordinates. So that means that the image is not fully on the software yet. So we are doing that to finalize the importation of this image. So now we just need to click right here and saving the map. And now we have here the Silicon Valley map that we can input in our scene just by drag and dropping. So after you had drag and drop the image, you can perfectly see it. Are you seeing any problem in your image? Because this is the moment that you still can fix it. Don't be ashamed if you, for anyhow, didn't pay attention and changed the X by the Y. We do that sometimes, there is no problem. The most important is always to validate your data because no one is immune to any kind of error and mistakes. So there is always a point that you can be tired or something like this. And if you don't validate what you're doing, you may pass through some kind of mistake. So now that we have already inserted our Silicon Valley map and did the georeferencing on it, we can now import our mesh from topography. So by importing the mesh right here from a local, we can import right here our mesh. So we are going to click on the topo. This is on the GeoFound building a model topo.dxf. Please tell me if you are not being able to import this way. So this is going to be the information of our topography, and we are just clicking on the OK. And this right here are some options for you. to take a look in your mesh if you need to remove self-intersections for volumes, invert mesh orientation, remove vertical edges, or something like this. So what we are going to do here, we are just clicking on the OK, and if we have any kind of error generated by importing this mesh, we are going to check out this again. So let's click on the OK. You can see right here the processing. So it was 3 tasks to import this mesh, and it had taken less than 1 microsecond. So we can see that the topo right here doesn't have any problem. We don't have any error being showing, and we can drag and drop to the scene to take a look how this is happening, how this is behaving. So we have here showing to us what is the surface and what is the underground. And if you forget what these colors are meaning, the first of it, if it's the first, is the top. If it's the second, is the bottom. And another tip for you is to pass really slowly the mouse on it, and you can see right in front and back. So now what we need to do, what is the step? We need now to drop it, to drop the map on the topography. So how we are going to do that? We are going to right click in our map and we'll be able to input in the topography. But at first, we need to make this mesh our topography. So we are going to go for the topography and do a new topography from surface. And we have our topo right here. So we are going to call it topography and just click on the OK. And now we have it as a topography. So if I drag and drop the topography, we will see right here that the colors of the top and the bottom for the topography, it's different. So it's yellow and green. So right here, if we go for the Sigan Valley map, we can just drop it on the topography now because we have the topography. And once I have done that, we have now the drapages object right here. So take a look on this file when I unclick. You don't have anything. When I click again, you have it. So here is the draped map. So now we have a map that already have informations. The first of all, informations from the altitude. And now the informations from the geology that we can also insert on it. And now creating the geological model and digitalizing what we are seeing right here. So at first, let's just create our geological model. So
Julia,
if we go right here, sorry,
can you please again show the process to get the map on the topo?
uh, right here on the Sigan Valley map, we are going to right click on it and click on topography.
Okay. That's it, no?
Yeah.
But it is not coming in this.
Do you want to share your screen so I can
Yes.
take a look on what may be happening?
Yes.
Arushi, your voice is not audible. I can't hear you, Arushi.
Can you see this now, Julia?
Yes, I know what you're saying, Babita, is really low, but I can hear here.
Okay, can you hear
So
now?
it is there. If you go to the drop edges object, is right on top. Drop edges object right on top.
Here?
That's,
Okay.
yes,
Okay, so
that's
we'll get
it.
it here. Okay, thank you.
Yes, I was showing this right now. Please tell me if my accent is hard to understand
No, no,
because
your
maybe,
accent is fine because like we are doing it here as well, na? So I missed the step, I think, looking in the
No, no
screen.
problem, no problem. So I'm just going to repeat that again because this is something that you will need to do a bunch of times, the draping.
Yeah.
So I'm just going to repeat again because it's pretty easy. I'm just going to take it out. So right now we don't have anything draped. We don't have the Sigan Valley draped. And how we are going to drap it? You see right here that the draped GIS objects, this file, it will always be here. So if you unexpand this, you will not be able to see. So you have to always expand the topography and check this file right here. We don't have anything dropped. Right now I have undropped mine. So the GIS object right here, I can right click on it, but please take a look on the dropped GIS object, what is happening. We are going to click and aha. Now we have it and it's saying right here on topography. Here we don't have written on topography, but here we have on topography because it is dropped on the topography. So now to see this, we just need to drag and drop. And in the same way that I was speaking before, if you don't remember, for instance, you have a bunch of data and you have everything closed, and you don't remember where did you get this map from. This is a link. So we can click on it and it's going to appear where is the file that you are getting this from. So if you don't remember which file this is dropped, just come right here and click on this link. But remember, if you're not seeing this dropped, check out the dropped GIS objects. It's going to be here, and if it's not here, it's because it's not possible to drop it on the topography. And then if it's not possible to drop on the topography, you have two main reasons. The first, because there is no topography. The second, if you have a topography and you're not being able to drop it, maybe those two objects are not in the same coordinates. So the program is not understanding how they would fit. So we don't have any of those problems right here because we have done our georeferencing and we have also checked if it was right or not. So now we just need to close this and we have it, our map, and we can go for our geological model. If you remember, on the geological model, we are going to just build a box to understand what is the solid that we are trying to look and if the topography is going right with it. So we can create a new geological model right here. But on the surface resolution, we are going just for 30 in this moment. We may change it, but it's just that 300 is too much. We don't have any base lithology column to input or not even no filter data to also input on it. So we are just going to call it geological model and click on the OK. So what are the informations that we can get on this model right here? We can get the information from the geological map that we have here a fault, and we have this fault going right in the eastern direction, falling for the eastern direction with the 60 degrees of dip. We have here the contacts between our lithologies right here. And we also have right here those informations that are coming from the structural data that we have it. So first of it, how we are going to understand our our model and how we are going to create those lines. So we already have our geological model. You can see right here that we have a fault system. And if we want to create a new fault, it can be from a polyline. And how we are going to do that? We can come right here on polylines and do a new polyline. And this new polyline is going to be called fault because we are going to drown it. So this is our fault. I'm just going to create it. And once I click on the OK, we will have right there and on top our editing tools appearing. So we just need to click on the OK. And now we just need to click right here on the draw lines. Remembering here is the place that you need to choose if you want to do the drawing on a slice. So if you want to do the drawing on slice, you just need to click draw 2D lines on a slicer. But in our case right here, we can draw the 3D lines right on top of it. So now we just need to create our line. And we can come right here and start clicking. If you want, you can just make a zoom in and zoom out and clicking here, here, and just following your leads. So if you right click on it, you are going to save your line. You don't want that. So we can carry on right here by clicking and doing our line. Here I will have just to do a zoom out. And then I can right click on it and save it. So now we have a polyline that is representing our fault, but this fault right here, we can just take a look. This for now, it's just a line. And what that means? That means that we still have no information, no further information around here. And what that means? That means that we don't have any subsurface information yet. So now that we have already drawn it, our fault, let's just take a look if we have our contacts from GIS. And how we can do that, we can just come right here in our little file that is around here. And we can take a look that we have contacts here. We have here the contacts on a CSV, and we also have the contacts on a shape format. So we can input the shape ones on GIS lines if you want to. And we can come right here on the GIS data, maps, and photos, and just import vector data. So if we import vector data, clicking right here, we can see already on shape our dark blue outline and our light blue outline. So just clicking on both of them, we can click on the first, control, and click on the second, and we can open it. So we just need now to click on the OK. And if we want a clipping boundary, we could input right here, and we are just doing the OK. And we can just input to filter data. And why we have input the filter data? Because it's saying to me that it doesn't have an elevation, and this is no problem because our elevation right here will not be interesting to us because we are going to drop it on the topography. So we have the GIS data right here. We are going to drop it on the topography again. So we are going to right click on it, on topography, right click on it, on topography. So we have here everything dropped on topography, and everything that is dropped is saying on parentheses on topography. It's important to take care with that because when we are doing modeling and we need to use the GIS lines, we need to have this attached to the topography, because if not, we are not inputting any information of elevation. And this can be a problem for our model because it will not make a sense. So now that we have already done this part of the little fault, we can now start and also dropping our information that we have on GIS. We can start now to think a little bit about our structural modeling. Why? Because on the structural modeling, right here, I'm going to right click on it. We can import planar structural data. We can import lineations, or we can do a new planar structural data. In our case right here, we are going to do our planar structural data, and it's going to be called our fault planar structural data. Why? Because now I want to introduce you how we are going to input the informations that we have that are from structural. So we have right here the information on our map that it's about our structural, and we are just going to input a bit of transparency, and now I'm going to click on the OK. Why? When we do the OK now for the planar fault, it's going to appear this new editing toolset. And what we are going to do, we are going to create now our little tiny disks. So creating our disks right here, we would need just to create it and what we are going to do with the size of it, because this size is too small for us and we don't have how to edit it. We can change the disk radius. So right here on this right down corner, we can see the disk radius and we can change it. We are going to change to 18. And by changing to 18, we can actually see what is happening here. So I'm just going to change the angle. We can see right here our disk. And one thing to pay attention is we have on top the red and we have down the blue. So what we are going to do right here, we are going to turn this way, because we know that our fault is going to that side. This is being told by our little sign right here in the geological map. And now that we have changed our disk radius, we have changed our disk size, we can just come right here and input, for instance, 3. And what is going to do is going to make our disk like this triangle. So what we are going to do with this tiny little disk here to see the dipping. The dipping we can see with this line that we are seeing right here. So if we don't want to see this line, we can just untickle the show dip lines, and we can also input a query filter, a display filter if you want to see the azimuth or the dip. And I am just coming back here to our little circle. So now that we have here, what should I change it? I should change the dipping. Why? Because I know that the dipping right here is 60. So what I'm going to do, I'm going to input 60. So now we have a disk that is a little bit more coherent with our data. And now that we have already settled this disk, we can save it. So now that we have saved it, we can create another one. And the point 2 that we are doing right here. And we just need to come a little closer and check that this one is a 65 angle. And let's check here if we have the right polarity. So no. And how we could do? We could change the polarity if we want. But in our case right here, we just want to change it around here. Oh. So now we just need to come back. Let me just check if I have. So I had saved the first one. I just need to do. Yes. And now we just need to start inserting the disks for our contacts. But as you could see, we could do right here in our planner, in our data, that we have this information, this structural information, and we can import all this planner data if we want. And how we could do that on the structural modeling, we are going to import structural planner data from color, from our to be, and we just need to click on the open. First of it, I want to mention that the formats that are available here is the CSV, the point that, the point ask, and the point text. So we are just going to click in all contacts and open it. So we can see the Z, Y, and X. We can see the dipping. We can see the dip azimuth, and we can see the polarity. What we could insert is we could insert the category. So if we want to, we can input that as category. So let's just finish. And now if you want to check out all your contacts, we can just input that. Oi, hello?
Yes, I was asking, like when we import the file, there's one option category, right? So how do we decide if we have to give it a category or text or numeric?
Okay, got it. So I'm just going to do it again so I can open the window also to show you. So we are getting here the contacts, for instance. So we have here, this is the X information. So when you drop down here, you will see that you have this information as a priority. So this is not going to be a number because this is your coordinates. And then you have the Y, the Z, the dip azimuth, and the polarity. What that means? That the program needs those informations to properly show the visualization of the data that you are trying to see. So what means that only the things that are outside those categories, we can determine if they are lithology, category, text, number, timestamp, date, URL, X color, or not imported. In our case right here, this is a category. Why this is a category? First of it, because it's not number. This is not numeric. Second of it, this is not the lithology. So we have here two lithologies. This is meaning green and pink. This is talking about context. So if I want to have this information right here, it would only fit as a categorical information. So this is not a lithology. We could import that as text too, but as text, we will not make a category. So for instance, we see that all this data right here is this G and P contact. If I want to see all the information there just from the GNP by doing a query filter, I will be able to do that if I import this information as category. If I just do that as text, it will be a no check, be able to construct any query with it. So this is going to be basically what you want to do with this data. If it's going to work as a category or a number, a timestamp, a date, a URL, or a color. Did I
Okay,
make
thank you.
clear?
Yes, yes,
Okay,
thank you.
you're welcome. So now I'm just going to give a break because we had reached the hour, the 10 minutes break for us, and we are coming back to do over the second to start to messing with our geological model and showing how this is going to be modeled. So coming back in just minutes, we are just
Gina, before going on, uh, is it possible to draw a 3D model using the borehole, and we can draw dip and strike in a 3D?
yes. So
Can we,
if you
would you like to give us example using the first data that Oliver project?
so you want to bring this structural data from the drill holes.
Yeah.
I will need to have the structural data on the drill holes to that. So I don't know. I'm not sure if the
Not the
Oliver
structural,
project has it.
yeah. Borehole, how to measure, how to represent, how we can draw dip and strike using the borehole in a 3D model. A drill hole, I
Yeah.
mean, not the borehole.
Yeah, I understood. No problem.
We, in the
So by import,
in the
tell me.
Oliver project, we have drill hole data sets. We created the model, so we can
Yes.
use that model, and how we can show that dip and strike.
Yes, of course. But Babita, I need to finish this project first.
Yeah, yeah.
I cannot open
After
the
this,
both
not
of them.
now, not now. After finishing this, yeah.
Perfect.
Thank you, thank you,
Yes,
thank
for
you.
sure.
Yeah.
So I'm going to give the 10 minutes break now so we can fresh up a little bit. And we are just coming back. Sorry, just 8 minutes late for the break, but last day it happened. So be back in 10 minutes. Hello, hello. So we are back to our project. So right now we have inserted all the contacts right here to check out if they are right. And they are. We are seeing right here the polarity is making sense. And now what we need to do, we just need to insert right here the disk for our fault. And our
Priya,
fault
your screen
was,
is not sharing.
oh, sorry. Thank you very much. Coming back, starting over. What we have here, we have the planner, structural data inserted, and we have our data for our fault. So the name of the data for our fault is the planner fault. If you find easier, just take out the others for you don't have any trouble confusing it. And you are going to edit again the object, open, close the editor, and start over. And what that means that if we wanted to change this one right here, we could. And if we want to do a new one, we just click here and do the same process. We are just come right here and we are going to apply 65. But also check if it's making sense, the polarity of it. And it's not, we just need to drop this for, oh, I have done a 31. So let's come back here, just editing. We are clicking right here on the little disk and we are creating for this side. We know that the red one should be on top. So be aware to put the pro side. And now we just need to click on the 65 and just click anywhere else. So we're still having the polarity, so we just need to flip the polarity right here if we want to make the same as the first one. So now that we have it, we just need to go check it if we want to save it. So you don't have any kind of trouble now trying to check it. And now that you have saved it, we can now close the editing part. So we can do the close editor here. And we have here our two disks to be modeled. So we have here one disk and we have here our another disk. Can you find any error here? So we are not using the same polarity on the both of the disks. So what that means? That means that we need to edit it. Because what is going to bring here? Something that it's not making sense. So what we need to do? We need to make this one right. So we are just going to edit again, come closer to it, and we can just click on it, and then we are just turning to the other point, and then inputting the dip again as 65. Now we have it right, we just need to save it. So we had checked that it's possible to import this information, it's possible to create those disks, and it's possible to edit those disks if you need, if you have the wrong side, or if you, when you are modeling, you have realized that the azimuth is a little bit different. And now we just need to save it and close it. I right here too. So we have here all the information that we need, and now we are going to do that in our geological model. Right. So we have right here our fault system. We know that we have a fault right here. How we are going to input this fault? we are going to right click, new fault, and this one is coming from a polyline that we have created. So just click on the polyline, and in this case, we are having an existing polyline. So let's select our polyline, that is our fault, and then just click on the OK. So the name of it will be fault, and we can just click on the OK. This is not active, so if we double click on our geological model, we can see right here on the fault system that we can make this active. And in a way very similar to the veins, if we have more than one fault system, we could insert an interaction type. So just to make it clear, we are not going to make this activated yet because we still don't have any information from the subsurface. We need to input the information that we have, that is the structural one. So we are going to go for the faults in our geological model, right click on it and add. We can see that we have several options right here. We could extract the want to add structural data. What is this structural data that we want to add? It's our planar without any parameter. And now we just need to click on the OK. So now we have our fault. We can drag and drop it to see if it's making sense or not. And we can see that it's not making sense. It should be to the other side, right? And how we are going to change that? We have several options right here, but we can just untick and remove our structural data right here and insert it later. So we have here our fault, and we have here now to insert all the contacts that we have. Why? We know we have imported all the contacts together so we can see the structural data, but now we have to import the planar structural data that we have for each of those contacts. So all of those little disks right here, they can be already separated and also have a line attached to it. And we have this on those CSV files. So if we want just to click, control click, we can just start to uploading it. So we will have here the same kind of advertising for us right here, and we can just click on the finish. So after we had finished the green and pink contact, we just need to do the same for all the other contacts. So we have done for the green and pink, we just need to do for the orange and yellow. And open it. We have the validation window, which is very important for us. And now importing local. And for the list, we are going to input the pink and orange contacts. So just the last window of validation, we need to right here, if everything is making sense, and just finish. And now we have all the contacts settled right here. And what we are missing, if we are talking about how it's the mainly way that we are using until this moment to do all of our surfaces is by creating on the surface chronology on our geological model. So right here, we will have to construct this model by the contacts that we have right here. And to construct those contacts, what do we need? We need lithologies. So let's click on lithologies. because now we are going to insert our lithologies. So, at first, let's insert our lithology pink. And of course, it will make more sense if we change the color to pink. And now we can do our green. And of course, we can change the color to green. Now we just need to do our orange. And of course, changing the color to orange. So we have the pink, we have the green, we have the orange, and we need the yellow now. So now we just have to create the yellow. I'm just clicking on the OK, but we have more than this, right? We have the green, the pink, the orange, the yellow, but we also have the light blue and the dark blue. So we are just going to click on the lithologies again, and we are going to open for the light blue and the dark blue. And now we just need to change these colors to the right so we don't get confused. So the light blue, we are going to input a light blue, and on the dark blue, we can input a darker blue. So the unknown is going to be behind everything. And now let's analyze what comes first. So if we check right here, what would actually come first and what could come second right here. So the green one can come first, then the pink, then the orange, then the yellow, or the opposite of it. We can have the yellow, the orange, the pink, and the green. But what is most important is to realize that we have here also a quaternary part of the deposit, that is the light blue and the dark blue. So now that we have already import all the informations that we need to start to build our surfaces, we will go for our chronology. So if we want at first to activate our fault, we are going to take a look what happens to our project when we activate a fault. So at first, let's just take a look. We have our project right here. Let's make our boundary box a little bit bigger by double clicking on it. And by bigger, I mean with the X a little bit more expanded. And here we have the X expanded into less 500, which is almost the same as we have on surface, and we can just click on the OK. So now we have a box that is a little bit larger. And what we could do, we could already activate our fault. Why? Because I want to show you what happens when we activate our fault. So to the fault system, click on activate it and just click on the OK. So you can see the processment happening right here. So 6 milliseconds. Fault block 1 and fault block 2. So what that means, let's clear our scene and take our block 1 and take our block 2. So this way, we have right here 2 blocks that can come together, but can be separately than the surfaces. So what we are going to do right here, we are going to start with our west block. So what we are going to do first, rename it. Why we have here just block 1 and block 2, this will not make sense for us if we want to analyze it. And if we want to see our block boundaries, which is very important, mostly if you are using a lot of faults, you will need that because you need to understand in which block you are messing. So now that I have just come right here with the right button with view fault block boundaries, we can see the 2 of them separated. So we can call the blue one, that is the 2, the west one. So we are going to right click on the block 2, rename, and write block west, and rename it. And on the first one, we are going to rename by block east, and we are going to rename it. So now that we have it right here, what we could do, we can already start our surfaces. And what I wanted to show you is that right here, when we are doing the surface in just one block, we will be able to, on the surface chronology afterwards, just do the copy chronology too. So what that means? That means that I'm going to do everything in one block, and afterwards I will be able just to copy to the other block, which is pretty nice. So now let's come back, talk about our lithologies. So I'm going just to input that again. Why? Because we can insert here our Sigan Valley map for us to understand what is the oldest, what is the youngest. So right here, we are going to consider that the yellow is the youngest. And also we are going to consider right here that the orange is coming after the yellow, the pink, and by list, the green. So we just need to click on the OK right here. And just opening again because I guess that my light blue lithology was not saved. And the dark blue. And we can insert it on top of it because they are actually the youngest. So now that we have already set the dark blue, the light blue, yellow, orange, pink, and green, we can just click on the OK. So we have now the same lithologies for the 2 other blocks. Hello?
Hi. How have we decided the young and old lithologies? Can you please explain again?
Okay, so this is going to be by the principle of Walter of sedimentology. This is geology. So it's going to be, you can see right here, this is going to depend on the interpretation, of course. So that could be an article explaining that, or can be any kind of chronological kind of stratigraphy. But this is a part that is the geological knowledgement that you have on the area to say what is the lithology that is going to be the youngest and what is going to be the older. So in this case right here, we are considering that this is a layer cake model. So what that means? That means that this is a sedimentary place. So by this place right here, this would be inverted, and we had on top the quaternary deposits that would be the dark blue and the light blue. But to be honest, this is not a very important part here because what we are trying to get is the tools that we are using. So, for instance, this is a pretend case that we had created. So this right here is not even has a name. It's just the colors of it because we want to show that what is important is the category and the numbers. So you can model this the way that you want it. You just need to practice what is going to be the best setting for you if you don't have enough knowledgements. So if you don't have enough geological knowledgements, you will have to use your expertise as a geologist to understand what is the oldest and what is the newest. And this is going to be basically by the stratigraphic rules that we have. So the Walter law is basically the law that is saying that everything that is sedimentary and it's underneath is older. So, and when we have a structural deformation attached to it, which is this case right here, we could move everything and have this a little bit displaced. But of course, if you want to consider the opposite of it, is also valid. It will not make a lot of difference here. It's just the coloring that make a difference. So just carrying on a little bit with this part right here of the surfaces. Why? Because we are going to carry on right here by the block west that we have right here on the screen. So at first, I'm just going to take out the block east so we don't have any kind of confusion. And we are going to unexpand the block east right here. And we are going to go for the surface chronology. Why? Because in our surface chronology right now, we just need to understand a little bit what is happening. So we have the information, and this information it's not coming this time for drill holes. So we are going to create here erosions. It's going to be basically erosion deposits here. And as we had already learned, how we could also do these deposits, we could also do as a new stratigraphy. But since they have different contacts, different angles of contact, we are going to do them individually. So the new erosion right now, the new erosion right now, it's going to come from theta, and we are going to click on it. So the first of them is going to be the green and the pink. So actually, we can start here by the youngest if we want. So we have settled in our little lithology right here. Just let me remember. We have settled here from the yellow. Why am I separating now the other contacts that we had previously, this dark blue and light blue? Because we are going to do that by the GIS data maps and photos. And I wanted to show you first how we are going to create the chronology for the other ones. But we can start actually by doing by the GIS line because I think it's going to make more sense talking about the rules that I have already presented to you. So let's follow the rules that we have set and start with the dark and light blue. So to do that, we are going to do the same. It's going to be a surface chronology. In this case, it's going to be a depositional, and it's coming from GIS vector data. So previously, we were taking from structural data, but now we are just going to take from GIS vector data. And on this GIS vector data that we have right here, we are going to select the first one. And which one is going to be the first one? The one that is more on top. So if we take a look here, we can see that the light blue is on top. So we are going to make the first lithology, which is the blue. And we are going to select it on topography, dark blue outline on topography right here, and just click on the OK. And then we can click on the OK, and we can check it right here. That it's making sense with our project. So now we will need just to do our second lithology right here. Let's just input the Silicon Valley map. We have done already our first lithology right here on our surface. And we can go for the second one. But this one is because we can see right here. Let's just look at down. Why? Because I'm seeing right here that we have actually fulfill what is the light blue. So what that means? That means that we should change it to the dark blue and the light blue, and just clicking on the OK. And this way we would have the contact now with the light blue. But what that's meaning? That I have taken the contact, the wrong contact right here. So I will need to delete it and go on the surface chronology again, a new deposit from the GIS vector data, and our lithology as the light blue and the lithology as the dark blue. I would select right here. And let's just check which one. So the light blue outline west should be. And just clicking on the OK. And now we have it right. So at first we had just taken the wrong GIS data right here. And what we could check that the surface was covering another data that was not what we were looking for. So now we have it on the place that we wanted, and we can carry on with our surface chronology. So we are going to right click now, and we are going to do a new deposit from this vector data. And this one, we are going to select it because now it's going to be the dark blue outline on the topography. And the first lithology, the youngest, is going to be the dark blue. And the second lithology, on this moment that we didn't have start the rest, could be the unknown. But if we want, we can already input our contact as the yellow, but it will not make that much sense in our project right now, since we didn't have modeled this, that it's a little bit behind it, based on our structural data. So we are going to input as unknown. And by dragging, dropping, we could see that this, for now, is working for us and is not interfering in the rest of the deposit. So why am I using these specific rules right now? That I am using is still the youngest to the oldest, but not exactly focusing and already doing the contact right here, because I have two different sources. I have GIS data, and I have also a CSV file as sources. So my first contacts they are based in my GIS data, but the other contacts will be based on the CSV informations that we had. How we could do that completely on Leapfrog, we would create those polylines, call it contact, the same way that it's here. We would create these planar points and attach it to the contact. So this way, we would have exactly the same. But it will take a little bit longer because right here I had just imported for us. So now that we have already created those two surfaces, we can go for the other ones. And on the surface chronology, we are just going to start right now by the yellow. So right here, we are just going to do a new erosional deposit. And this case is coming from structural data. So my first lithology here, it's going to be the yellow. And the second lithology here, it's going to be our orange. It's just, oh, sorry, I closed. So coming back here, erosion, we are coming from structural data. And we have here the first lithology as yellow, and we have here the second lithology as orange. And now we just need to click on the OK, and we just need to go for the yellow and orange contact. And then we are just clicking on the OK. Now let's check. It is making sense. We can also input right here our Sigan Valley map, the one that is drafted. So we can check if it's making sense, and it is. Now we just need to carry on doing our geological contacts. So just to make our scene a little bit clearer here, I'm just going to take everything out and input the Sigan Valley again, remembering that I have a little bit of transparency on it. And now I'm going to look down. So now we have our first lithologies. We just need to go for the other ones. So on the surface chronology right here, we are going for erosion, and this time from structural data. Again, remembering all the ones that we are doing here are coming from structural data. And now we are just going for the other contact. So we have the contact with yellow and orange. Now we have the contact of orange and pink. Orange and yellow, orange and pink. And now we just need to click on the OK. Existing structural data, and it's going to be the orange and pink. And now we just need to click on the OK. From this side, we have the orange, and from that side, we have the green. So our surfaces until this moment are making sense. So now we just need to go to the surface chronology and carry on. New erosional contacts, this time also from structural data. So now we have structural data, click on it. The first lithology right here, it's going to be the pink. And the second lithology, the older one, it's going to be the green. So now we just need to click on the OK, input existing structural data, and then we are going to input our last one, green-pink contact, and just clicking on the OK. And now we have it. So Oh, sorry, let's look down. And now that we have everything that is inactive, let's take it off and take a look if we have the green pattern right here. Have it. So in our lithologies right here, what we can see that the dark blue and the light blue should also be an erosional. So what we are going to do, we are going to open it and we can change the contact type. We can input erosion and the second lithology can be the yellow. So let's check what changes. And now we can do the same and inputting the contact type and just hit OK. Now we are going to activate everything in our block model. So let's open it, click on everything, and input the right chronology on it. So what it's going to be? It's going to be the dark blue and light blue contacts, yellow and dark blue. We are going to have the yellow below, the pink, the yellow, the orange and pink, and the pink and green. And the background lithology is going to be. And now we just need to click on the OK and clear our scene and get our block. So here, our first pass modeling for this side. And how we are going to do for the other side. We are just going to click right here on the surface chronology and copy chronology 2. And right now, we are just copying the chronology to the GM fault block E. And now we just need to bring this to the scene, and we can see that the surfaces are making sense, and we can activate it all in our block model. So far, do we have any doubts on it? Because we were a little bit faster here actually, and this model is finished. So we can now, after the interval, go back to the Oliver project and take a look on the structural data that we have there. Or I can take a look here because I have other projects that have more structural data, more interesting ones, and I can show you from this other project too. So I think I'm going to give the interval a little bit earlier if there is no doubts, but I can wait until the full hour here. Please, if you have any kind of doubts, this is the moment. We have here our model. We just need here on the fault block E to open it and OK. And we can see our little model right here. If you want to constrain more right here, your light blue, what we can do, we can come here on the dark blue, open it, and on this one, we are going to have a contact type as deposit. Oh, the boundary is a little bit over, that's why. Because if we input right here, we can see that the boundary is ending right here. So we had expanded a little bit the boundary, and that's why it's making the lithology altogether. But we had decided that when we choose this boundary, if we want to be exactly the same as the map, we should have input a boundary extent that is exactly the same as our map. So we can do that now just to show how easy it is. And we can do that by changing this part right here. Pressing D and coming closer with the boundary box right here. And then just clicking on the OK. And now our block is going to be exactly the same as our little geological model. So you have understood that we can input those disks directly here on the structural modeling. We can build those contacts directly on polyline. We can build the faults on the polyline. We can input the informations of structural data of the faults already in our geological model. So right here, if you take a look on it, we can extract a G's line from it. So if you want already a shape line for it, we could just extract it. So we are going to see right here in the GIS data maps and photos, the fault extracted right here. And if we want to just put on topography, we could right here. So if we want now, for instance, to change it, I don't want this fault anymore. I want the fault that is dropped on the boundary. How could I do that? I just need to take this all out. And I'm going to take out the fault. This is all going to be reprocessed. And we are going to do over. So we can remove it. And all of our model is going to be affected by it. So what is going to happen? Our model will come back to be just one. And how we are going to do now to make this two again? We can make the fault system again. A new fault, this one is coming from GIS vector data. This GIS vector data, it's on topography. Remember that, drop a GIS objects, fault on topography. We are going to click OK on that. And then we are just going to add our structural data on it. And our structural data, it's our planar fault that we had created. Click on the OK. Take a look on it, which is making total sense. Taking this out, coming back to our geological model. And now we are going to open it and make our fault active again. So I'm trying with you here two methods. The first method, we have done the fault and then do the surface in one block and copy to the other. Right now, we are pretending that we have done the full block and we are putting the fault afterwards. So we can see what happens when we do that. So we have done that. And now let's take a look again in our fault block boundaries. So we have here our fault block boundaries. We can click on the block 2 to realize that this is our block west. So we are just going to the renaming and we are going to call it block west and rename it. And now on the block 1, we can rename it and put as block east and then just rename it. And now we have our lithology splitted again. Let's check how it's behaving. It's making total sense. And it's making total sense. And we have here our fault. It's following exactly the structure that we have done for it. And we have our model totally done without drilling holes in just 1 hour. So there is any doubts here? If not, we are going to take our 10 minutes break and I'm going to come back, talk a little bit about the structural data when we are getting from drill holes, and then we will have our Q&A section. What do you think about it?
Yeah, sure.
I'm fine with it.
Okay, so in 10 minutes, I will be back. Coming back to our final part of our 4-day course, I am starting to share my screen again. We have right here our model done totally by the geological map and also with the structural data that we didn't have mentioned that much. Now I just need to close it, and I wanted to show you one more time how to do that. We are going to save a zipped copy, a processed one, and we can just click on save after inputting the name right here. As I have already created this project, I'm just going to cancel right here, but if you want to do it, you can. So now I'm just going to close it. Remembering I'm not releasing the seat, I'm just quitting. And I'm going to open our previous project. So the one that
Priya,
we are, wait, tell me.
I need to. There's one area where we have the lithology. Okay, can I show my screen?
Yeah, yeah, for sure.
Can you see this part in your model? It is not connecting
Yes.
here. How do we fix it? If you check your model, the pink one is closing here like this.
Okay, just let me check 1 second. Oh, sorry. I am just sharing the wrong screen. Well, here, so you are taught, let me just get the Silicon Valley map. Oh, got it. This part right here. So let's check the surface that was created because this surface right here, which one this is, we can see that this is coming right here. So what this is meaning, probably, that if we input here a different kind of surface, maybe because it's erosional, I'm going to take a look right here on the block west, because we don't have this problem on the block east. It's just a surface that is not getting to the place. So the things that we could do right here. First of all, we need to find the right surface. So let's take out the block east because it's not necessary here. It's stuck it. Just wait a minute. My computer is stuck it. No, done. And here we just need to find the right contact. So let's take out, we have here our contact. We can take a look on the green and pink contacts. So we can open it and check out what is happening because if we input the green and pink contact, this is getting into here. So first of all, on the lithology, we can try to swap the contact type to deposit to see if it's going to change something, but it doesn't. So what are our options right here? We could, at first, start trying to make a line to push this over here. But you can see that actually the program had catched here a problem in our map because our map is not making a lot of sense this way. So how we should build this to actually come up right here? We would have to actually do those contacts before doing the contacts that we have right here on top. And why that? Because we have different directions. So this would be treated actually as two different sequences. So to have this a little bit more feasible right here, we could start modeling by the first stratigraphical sequence. And what was the first stratigraphical sequence? The yellow, orange, pink, green. And afterwards, we would put on top of it this erosional surface. So why we don't have this getting into this point right here? Because we are disrespecting the law that we have already created, telling that this was pretty younger and didn't have any contact with this right here. How the program is going to attach those two? It won't. So how we could fix this? We would have to take out the dark and blue contact. So we would have to delete it. And let me see, I have here the green and pink, the pink and orange, yellow, and the yellow and dark blue contact that I would have to delete it either. Let me just come back right here to the original type. And now I'm just going to delete the dark and blue contact. And coming back again with our project, we would have to start over this sequence that we have done here. So let's do that. The other way that we could also have done, we could come right here to the pink and orange contact from the west boundary, that is the one that is giving troubles to us, and ask for this pink and orange contact to follow our polyline. So we could create another polyline and edit that surface. Why we didn't have done this? Because editing, adjusting the surfaces is a little bit more advanced. And at this point, this can give you a little bit of trouble on the processing. So what that means, the much more features you have attached to one surface, biggest your problem is going to be when you are starting to build your model. So we could now, to make it easier, start to construct it over again, but we are going to do that by creating first what is down and afterwards what is eroding on top. So we would build our first erosional from our structural data and starting now from the yellow, which is the youngest, let's come back our little map right here with the yellow to the orange, just clicking on the OK, existing structural data, and right here, the yellow and orange contact, and just clicking the OK. Let's see if this is already going to fix, because we don't have this problem right here on the other side. So we can see that this problem is being generated by the interaction of this contact right here that wasn't having any interaction with the pink contact. And this way the program is not going to have this contact so close. So now that we have already created our yellow and orange contact that it's already here, we just need to create the next one from structural data, and it's going to be the orange first and the pink after. And just clicking on the OK. And I forgot to pick up the pink and orange contact. And we can import right here to check if it's right. Oh, sorry. We have a... Let's do again this pink and orange contact. So the surface chronology, we are going to build this new erosion, and we are going to do that from structural data. And the first lithology right here is the orange, and the next one, it's going to be the pink. And we just need now to put the existing structural data that is going to be the orange and the pink, just clicking on the OK. And we have this right here following the right pattern that we need. And now we would just need to do our new, but this case we are going to put the pink as the youngest and the green as the oldest, and just clicking on the OK, existing structural data, and we are going to input the green and pink contact. And now we just need to insert this, and we can check already if this is catching what we need. So right here, we would just need to, on the topography, get this a little bit lighter. Get this a little bit lighter. And we are still having this little issue right here. Just let me check if we have this issue actually on the GYS. So let me see. Yes. What is the main question, main problem that we are having right here? If we want to make this boundary go into this part right here, we will need to do a polyline to help it. But one thing that is not making sense for the program, what we have inserted right here as the dip is going to be enough to meet the surface. So what it's going to show us? You can see right here, looking east, this will also be a validation for your geological map. Because if we check right here on easting, if we are following this rule that we have inputted this rule for our model, it would not go over. It will meet the surface right here. So if we want this differently, we would have to draw the contouring. So we could just draw the contouring on the second map. I'm just going to collapse all the rows. So we could take a look on the second valley map that is not showing right now because my hardware is a little bit doing a lot of noise. But that means that we have the Sigan Valley map right here, and we could draw the lines on top of it. So the same way that we have these lines drawn right here, we would draw the lines for the pink one. And in this case, we would go in the geological map right here, and just on the west, because this is happening just on the west, we would input here on our project the green and pink contacts. We'll have to add more points or add the GIS vector data. And if we add this GIS vector data, it's going to be expanded into the blue right here. So this is going to be the easiest way for us to sort out this tiny displacement. But if I was the geologist modeling this, I would consider this as a correction to my model, my map, because it would not make a lot of sense. If we were two things must be wrong there. One thing must be wrong. Or the structural data that you catch on the field is going to be wrong, or you have to change a little bit uh, the deviation of this structural data. What that means that you don't have anything that is straight. You may have a curve on it. And when we have that, we are talking about a more complex kind of geology, and we will need to use the support of the polylines. So we had already checked it today how to do the polylines. Actually, yesterday and the day before, we also used the polylines. But just to remember, if you want to do one, you can do a new polyline right here. And if you want to bring this to the gist vector, we can bring right here. So now that we have already talked a little bit, a lot about the Sigan Valley map, let's go to the Oliver to see if I will be able to open this right here. So let me just close some things else. And now let's open our project from the Oliver, because I wanted to show you how we are going to extract the structural data that we have on the drilling and how we are going to bring this to the structural data. So let's wait for the program to open it. And now we are just going to clean our screen. I'm going to collapse my rows right here. And after that, I'm just going to bring in my drill hole data. And on this drill hole data right here, we can just check what we could take from this drill hole. So we could import from file, planar structural data. So how we will do that? Drill hole, import from file, planar structural data. Let's click on it. And then we can bring this to our geological model or our structural modeling. So just remembering, if we want a new planar structural data, we are going to do right here. If we want to import our planar structural data, we are going to do right here. If we want to import lineations also, and the clustering structural data, what is going to be there? It's when we have a lot of content of data in the same place. So now that we have already checked a little bit of our data, how we can take our data, how we can take more information also from what we want, let me just think if there is something else that we could take a look here. We could export, I already told about exporting errors, viewing the relationship and how we could do that. We can take a look on the structural trends right here to do a new structural trend, just clicking on it. It means that you just need to have some data to input. So clicking on the plus right here, if you want to do a structural trend that is based in my vein, for instance, I could do that. And we could actually use any kind of volume that we have right here for it. And also the boundaries that we have used and things like that, they are all be kept right here. And we would just do the input a range on it. That is the size that we want this to be fitted right here, and the strength that this is going to have it. So I think that just one last thing that I wanted to mention about, it was a bit about the ISO values. I think that's right here. This is the topic that I wanted to mention because we have done yesterday a little numerical model, right? And on this numerical model, we have the ISO values. And we had a question, a very interesting question yesterday about the ISO value and what is going to mean. So the ISO value it's basically is an indicator for the RBF interpolants, and it's based on probability. So that's why the data, the number right here, it has to be close to one, and that's why also this number right here, the one will be very important because it will be the best probability. So the ISO values will represent a little bit of the shell that represents the volume for each numbers that we are taking. So if we select the zero point 0.3, there is a 30% probability that any point inside of the resulting modeling will be less than the specified cutoff value. And this way we are going to go on. So this will be the mainly explanation for the ISO value. And when we have the one, we will have exactly the one that we have selected for our cutoff. So this will be mainly the information, the general informations. And now I just want to mention a little bit the Sequent Learning Center, because from now on, everything that you want to work with is going to be in your Learning Center. So you have checked how I have entered right here on Leapfrog. We are going to input Sequent Learning Center right here and click it. The browser will open and you will be on your logging of the Sequent ID. So if you have a Sequent ID, you already will have access to some parts of it. And if you have the license, you will be able to access everything. Remembering, you will have the license that was set for the IRH until 20 or something. And you can use all of those features during this time. So I was mentioning geotechnical domain. We have this right here. I was mentioning a little bit of geochemistry. We have right here. And the one that I want you to look is this one right here. So the Leapfrog Edge fundamentals. I'm going to pass this for you because it's going to be a further step that is very interesting for you. And another thing, if you want to revisit the courses that we have done right now, we just need to go to the catalog. And right here, you can call from for the ones that we have checked. So we have checked the Leapfrog Gel Fundamentals until the 8th module and with extra content. So if you want to redo that, you just need to go for the contact types, see that we have courses and learning paths, the category, that if you want in a different language than English, first select the language and then the product. And right here, we can select also the product that in our case is going to be Leapfrog Geo. So you can see all the courses that we have, including Leapfrog building a model from a map, exactly this one that we have talked about. If you want, the compositing is already here for you too. We have a little bit more extra on the structural modeling. And remember, this is all oriented. So we have created this course to be taken fully online, and you'll be able to do the step and check it if it's right, do the step, checking if you're right. And right here, we will have saying if this is basic, advanced, or intermediate. So I would say to you to do the intermediate ones and probably going for the structural modeling now or the edge. Enjoy while you have all the full access for this platform. This is very, very resourceful. So as a team, we had built that based on several trainings on several clients, on several feedbacks, and the join of several data sets too. Now let's talk about when you had a doubt on Leapfrog, what you're going to do. First of all, you are going to check if you are seeing these interrogator points in any place, because this right here will mean that you have an option of help that is going to make a little of an explanation on the topic. If you still need support, you can go for the Leapfrog forum. So on the Leapfrog forum that I have just clicked on, this is a big, big community. And this community, we have kinds of items. So if you need here to understand what is the latest version, some tips, or about thickness or any specific subject, you can come right here and search for it. And another thing that is pretty nice is if you want to contact us, you can just click here and you will be able to already have the forms of the um, the support. So that means that if you are really stuck it in any place, you can go for the support and we need to answer you in 24 hours. That means that if you have any kind of questions, and believe me, there is no stupid question when we are talking about softwares in general, you can send directly to us and we will be able to respond it in the closest time possible. So,
Julia,
tell me.
suppose if somebody is out of UAE, some another country, and he or she want to use Leapfrog by connecting to their home Wi-Fi, they can do it. It is not
Yes.
constrained. Not constrained.
No,
IRH server should be connected.
no. It's not.
Okay.
The only thing that would be constrained in some countries could be the cloud. But we don't have the cloud here. We are not using Central. So if we connect it to Central, then there is some places that have policies for cloud information. But this is
I'm
not the
talking
case
about
right here.
IRH license.
What you're talking about?
I'm talking about IRH license, the license we have taken. If somebody is
Mm-hmm.
out of UAE, we can use there, right? From home Wi-Fi.
Yes,
Yeah.
UA, you're saying European Union.
No, we are in
You
Abu Dhabi right now. If
okay.
somebody is traveling Zambia or somewhere else, right?
Yes, is global.
Okay, thank
It
you.
will not work actually, I think probably in China, but China, Russia, and I think it's that mainly. It's just the places that are not covered globally by the company. So the company works on the EMA total territory. This is the territory that I work for. So right now I am in Porto, Portugal. And yes, we can use the license everywhere. I had worked in Brazil with this license. I have worked in Norway with this license. I have worked in Mozambique with this license. So you will be able to use your license everywhere.
Okay, thank you.
You're welcome. So if you don't have any more doubts, I would just say to you about the next steps. So I'm going to send through the share file link the projects and also the recordings. The recording, I am just sending the one from today. I think you can access the links from the other days. And also, I need to send you the certificates. So just to mention, the certificates is also based on the participation. So I will need to check a little bit the attendance afterwards, and I can send you the certificates at top until Monday. So please tell me if you need something specific on your certificate. Otherwise, this will be mainly all that I will have to show you. If you have any kind of question, I will give you my email right here on the chat. Although you already have it, and of course, we are always on the support line 24 hours. There is always someone in another region working on those hours. So if we are far away, don't worry because you will have someone in your time zone to attend you. And it will be mainly it for today. I hope you had enjoyed it. I hope you had learned something from here. And I hope you carry on learning because I know that on the first times that we are learning something new, it can be a little bit frustrating. But after we insist a little bit on it, you can see that this is very user friendly. And as I could see, some of you already use DataMine, and I swear to you, it's more user friendly than DataMine. So if you don't have any more questions, it will be mainly it for our training.
Thank you so much, Julia, for the 4 days training session. It was amazing. And questions for now, I have asked already, but once I start working and practicing, then I might have more questions, so I can send you an email.
Perfect. So this is the right process. I'm going to say to you, it's normal that you don't have any doubts right now, and the doubts are going to arise with time.
Yeah.
But don't worry about that. I have already mentioned we have the forum, we have the support. You can always revisit also the recordings that we have. So it will be very smooth.
Thank you.
Thank
Thank you so
you,
much.
Julia. If any doubts, can I email you?
Yes, I will say due to our time zone difference,
Yeah.
it will be faster if you fulfill the forms. But because when you do that forms that I have shown, when we are right here on Leapfrog, let me share again. So when we are right here on Leapfrog, we can go for the contact us. And then you can contact the support right here. So if you do this way, it's going to be actually faster.
Faster, okay.
Because this way right here is going to be direct for someone that is on your region in the same time zone as you.
All right. Thank you.
You're welcome. But of course, you can send me too if you find that it's very specific or it's
Yeah,
something
I
that
have
you
not
would
got
like to have.
answer of my question. How we can uh, create 3D model using our drill hole data, and we can show that dip and the strike direction. Possibly regarding this, I will contact you or I will send a message to support team.
Okay, you can send me this directly too if you want to. There is no problem because this is related to the course. So today I can already make an article maybe that you can understand better because I think that I wasn't pretty clear here. So maybe writing is going to be easier
Yeah.
for you to understand
Yeah,
because it's
right.
really, really, really easy. You just need
Yeah.
to right click on the
Yeah.
drill hole and export the
Yeah,
structural
sure,
data.
sure.
But I'm going to show the print screen and do the texting. I think it's going to be a little bit easier for you. So any doubt that you have from the course even, and you think that you want this explained on text because it wasn't that clear for me with me talking, you can do that. Just send it directly to my email.
Yeah, sure, sure. Thank you
Okay.
very much. Thank you.
Thank
Thank you,
you.
Julia.
Thank you very much for your time during these 4 days and for your patience. Please be resilient. I know that it's a little bit frustrating on the first steps when we are dealing with something new, but this is very user
It
friendly.
was
It's
not
going to
frustrating,
take
it was
just a while
interesting.
for you to be a pro.
It was not frustrating, it was interesting.
Glad that you like it. Well, thank you very much. Bye
Thank you.
bye.
Thank
Thank you
you.
so much.
See you.
Bye.
Thank you.